This is a static equilibrium problem. So what you have is three forces. Two are pulling up and in opposite directions, and then you have one that's pulling straight down. So to be in equilibrium, each of these forces needs to totally cancel out with the other forces to end up with a resultant of 0. So what you know usually in these problems is that you have a force directed in one direction with a specific angle, you have another force directed in another direction with an angle, and then you have a third force which is pointing straight down. So if we label these a certain number, just so that we have it, we can figure out different things about these forces. So force number 1 is up and to the right. So that means it's got a positive x and it's got a positive y. And how do we find these? Well, to find x, what we actually have is a triangle. We have the hypotenuse that's pointing upward. You have the other things pointing like that. So then you have your right triangle. So to find x, that is going to be the hypotenuse, which is your force, multiplied by the cosine of your angle, because that's going to find the x part of the triangle. And then likewise, to find y, it's the same thing, except now we use sine. So that's what we have to find your components. Now, positive and positive, so that will keep things straight. So then we look over for number 2. Same idea, we have a triangle, so we want to find the pieces, but for this one, for number 2, we have a negative x and a positive y. So then to find f2x, it's the same as we found f1x, it's f2 multiplied by cosine. Same thing for y. So that ultimately what we have is the same thing on both sides. So we have f1x. We have f1x to the right, f2x to the left, f1y up, f2y down. And then f3 is entirely y because it's pointing straight down in the y direction. So if this situation is in equilibrium, like you're supposed to be, what that means is that the sum of all forces have to cancel out. So the sum of every single force in each direction ideally should equal 0. So the sum of fx and the sum of fy. Now if you look at the forces that we have, for fx we have 2. We have f1x and then f2x. So because there's only 2 forces, and together they should equal 0, what that means is that f1x and f2x should be equal in size. Because the formula to get net force is the sum of the forces. So what you have is 0 equals f1x plus f2x, and then f2x is negative, so plus negative f2x, bring it over, so those two are equal to each other. So that will help you to find what's going on over here. So these two should be equal, and then our y relationship is going to end up, because that should also be 0, we end up with f1y plus f2y, and that's equal to the entirety of force 3. Because we have 2 forces pulling up, 1 force pulling down. Because of that, in order to cancel, the 2 up have to add up together to equal the 1 that's pulling down. And that'll give you those numbers. So then, depending on what it is that you know, you can find all this information with 1 force and 1 angle, because you know that f2x and f1x always have to be the same. Since they always have to be the same, as long as you know one side, you definitely know the other. And if you have the angle on the other side, you can find the hypotenuse, you could find the y, you could find the downward. So based on this, if you know f1x, which would be f1 times cosine of theta, f2x can be used to figure out what f2 total is. So f2x would be f2 multiplied by the cosine of your angle. So if you're looking for f2, f2 is f2x divided by the cosine of that angle. As long as you have the angle and you have f2x, you can find f2. And then once you know f2, the same thing can work to find f2y. Because f2y, like we said, is f2 times the sine. And then once you know f2y, and you can figure out f1y, you put those together to get f3. So altogether, It really comes down to just being able to break it up into the triangle. So as long as you have a force and an angle, you're good to go.